The fourth rule of differentiation is about what we call the sum rule. The sum rule simply tells us that if f and g are functions, and if h is the function defined by h of x equals f of x plus g of x, then if f prime of x and g prime of x exist, h prime of x is f prime of x plus g prime of x. This simply tells us that the derivative of the sum of a finite number of functions is equal to the sum of their derivatives if these derivatives exist. Now, to make it simpler, to find the derivative of h, all we have to do is to get the derivative of f of x and get the derivative of g. Then if the operation here is plus, the operation also here is plus. If this is minus, then this will be minus. So let's try to find the derivative of h of x as x squared plus 1. So given this, we have two functions, x squared and 1. And as stated here, to get the derivative of h, which is h prime of x, all we have to do is to get the derivative of the first plus the derivative of the second. So that is the derivative of the first, which is x squared. The derivative is 2x. And the derivative of the second one, which is 1, that's a constant, so derivative is 0. So that is 2x. If we have 5x raised to 4 plus 3x, then the derivative of that is, take the derivative of this, 20x cubed, and the derivative of this, which is 3. If f of x is 3x raised to 5 minus 2x raised to 4 plus 7x minus 8, then the derivative of that is, the derivative of this, we have 15 x raised to, subtract 1, 4, minus, multiply, it's 8 x raised to, subtract 1, 3. 7 times 1 here, so that's 7. Subtract 1 with x raised to 1. So that's 1 minus 1, we have 0. So that's x raised to 0, or simply a constant 7. If we have this function, so the derivative of that is 9 and 7, we have 63. Subtract 1, so that's 6. 3 times 4 is 12. Subtract 1, we have 3. Multiply 5 and 2, we have 10. Subtract 1 here, so we have 1. Minus 6 times 1 here, so that's 6 x raised to, however, that will be x raised to 0, or a constant, plus 0. So the final answer is just 63x raised to 6, 12x cubed, minus 10x minus 6. So that's about the sum rule.